Hey, I'm Mitchell, and welcome to another video in the RSP educational series. In today's world of industrial automation, power isn't just about keeping the lights on. It's about efficiency, precision, and reliability. That's why today we're talking about active power, reactive power, and apparent power. These are at the heart of every automation system, and they impact everything from energy costs to equipment performance. In this video, we're going to explore how these three types of power interact in AC systems and why understanding them is essential for designing and optimizing industrial automation processes. Whether you're sizing a transformer or improving power factor or even preventing equipment failures, mastering these power components can transform how your systems perform. If you like this kind of content and want more educational videos, please like and subscribe. Also, this video is for educational purposes only. Always consult a professional for your application. RSP Supply is not liable for any misuse of this information. With that said, let's get right into it. So let's start with the three types of power in an AC or alternating current system, which is very common in industrial automation environments. Active power measured in kW, kilowatts. So active power is the real power consumed by equipment to perform useful work, like running motors, lighting, or heating. It's the actual power that results in actual energy transfer. Active power is the component of power that directly contributes to the operation of devices, converting electrical energy into mechanical energy, or into heat, or into light. For example, in a motor, active power is what's driving the rotor, powering mechanical work. Active power is measured in kilowatts, kW, and active power is found in motors and machines and factories where they draw active power to drive processes like conveyors, pumps, powering control systems. It directly impacts energy efficiency since this is the power you pay for in utility bills. Industrial automation relies heavily on optimizing active power to ensure efficient operation of processes. Secondly, there's reactive power. This is measured in kVAR. Reactive power is the power that alternates between the source and the load without being permanently consumed. Reactive power does not perform any useful work, but it still is essential for maintaining the electric and magnetic fields required by inductive loads like motors and transformers. You could say it's a byproduct of AC power systems. The energy required to establish the magnetic field, and it's not permanently consumed, but instead is stored in the inductor's magnetic field. This energy oscillates back and forth between the inductor or the motor or transformer and the power source as the AC current changes directions. This back and forth energy flow is the essence of reactive power, and this phenomenon occurs because the voltage and current waveforms are out of phase. Although reactive power oscillates between the source and the load, it does not result in a net transfer of energy over a full AC cycle. It's essential for maintaining the system's functionality rather than performing useful work. Inductive loads require reactive power to establish and sustain those magnetic fields that are so essential for their operation. This kind of reactive power does not perform any useful work, but it still is critical for the proper functioning of AC systems and the operation of inductive components. Thirdly is apparent power, kVA. Apparent power is the total power supplied by the source, which is going to include both active and reactive components. It represents the total capacity of the system. Apparent power is measured in kilovolt amperes, kVA. Apparent power is crucial for sizing transformers, generators, and power distribution systems in industrial facilities. Properly managing apparent power ensures the system's electrical infrastructure is neither overburdened nor underutilized. So their relationship together, these three components of power, forms the power triangle, so to speak. These three types of power, they're geometrically related in a power triangle. You can envision this as active power or kilowatts, and that's on the horizontal axis. Reactive power, kVAR, is on the vertical axis, and apparent power, kVA, is the hypotenuse. So what does all of this have to do with industrial automation? Primarily energy efficiency. So by optimizing the power factor, reactive power is reduced. This is going to lower energy losses and decreases utility bills. Capacitor banks and active power factor correction devices, they're often used to minimize kVAR, or reactive power. Equipment protection, that's another focus here in this power triangle. So excessive reactive power is going to overheat components, it's going to degrade insulation, and it's going to reduce the lifespan of automation equipment like drives and relays. Load characteristics is also to be taken into mind. Industrial machines often have inductive characteristics, like motors, transformers, like we said. Monitoring active power in kilowatts, reactive power in kVAR, and apparent power, kVA. This kind of monitoring is going to help maintain proper load balance and avoid penalties for poor power factor. Monitoring and control. So advanced industrial automation systems use SCADA and PLCs to monitor these power components and automatically optimize power usage. By understanding and managing active, reactive, and apparent power, industries can optimize their energy consumption, enhance system reliability, and lower operational costs, which is essential for efficient automation. Thanks for joining us on this journey to better understanding the fascinating world of power systems. This video is just the beginning of an exciting series exploring active power, reactive power, and apparent power. In each upcoming video, we're going to dive deeper in more advanced concepts that will help you master the intricacies of power and its applications. Whether you're a seasoned engineer, a student, or just curious about the unseen forces that power our world, this series is designed to challenge and inspire you. For hundreds of thousands of other industrial automation products, go to our website. Also, for more information and other educational videos, go to our website, rspsupply.com, the internet's top source for industrial hardware.